Hello, this is the second part of the hurricane preparedness module, and we're going to be doing that. So this won't be as long as the other two, I think, but let's do this. I'm going to share my screen. And the first thing we're going to look at is the National Hurricane Center. If you ever want to go here to this website, just put in a web search for National Hurricane Center, you'll take it right there. And I'm looking at some educational resources. This might be something you want to take a look at. And the one I'm looking at here is the storm surge, because we're going to be talking about that. So this is just a place for you to find more information if you want to add to that. And understand there's a difference between the increase in the water on shore, the inundation, if you recall that word, inundation, where water is where land's supposed to be. You couple that with tides, which is a gravitational change of the water level that's coming from the moon. So if we have surge and tides, it can be really devastating. If the tide is low when a hurricane hits, then that's going to mitigate the amount of damage that a storm surge can do. So you can take a look at this. You've seen some of these pictures. We're going to talk a lot about this surge going on. Some interesting vulnerability facts for the storm surge is that population density from 1990 to 2008 increased by 32% in Gulf coastal counties. So most populated areas are less than 10 feet above mean sea level. So, this is the reason we have a lot of problems. People are taking the risks of getting impacted by major hurricane storm surge. And so that's going to be kind of an important thing. So what I'd like you to do is I'd like you to at least cut and paste these facts. I think they're kind of interesting that you would have to put into your notes. Okay, now where is my hurricane? Oh, I think I went past it here. So I'm going to go back this way to my METED. And that's not it. No, I'm looking at it. Here's the latest satellite. Hold on. I'm going to pause just for a second. So where's the recording? Hold on. Nothing like technology, huh? Recording is tough, but here we are at the METED, so a little bit of a jump there. But we're going to go to the community hurricane preparedness. We did introduction to basics last time, and we'll do forecasting in the following ones next time. But for now, let's go to hazards. So if you click on this is kind of a bad menu, but that little arrow is your menu. Okay, so here we are, tropical cyclone threats. And we talked about a storm surge. This gives you kind of a before and after. So when we look at the major damage coming from a hurricane, it is the storm surge. It is certainly the most devastating. So that's going to be a test question. What's the most devastating part of a hurricane? The answer is storm surge. It's the most deadly if it's along the coast. Keep that in mind, because if it's inland, it's going to be flooding. The winds are dangerous, but it's the storm surge that does most of the, creates most of the fatalities. So we're also going to get flooding inland from heavy rains. There's going to be high winds, and sometimes there are tornadoes, although they don't tend to be as prolific in killing people as maybe the tornadoes through the high plains, through the central United States. So keep in mind that there's a lot of information here about different impacts and how this is going to play itself out. So make sure you've read that before you take your quiz on this. So the storm surge is the greatest threat to life and property. We know that Katrina did a lot. That was a really bad event, killing 1,500 people. Most of them were attributed to the storm surge. However, a lot of it was a result of the levees that failed. This is a way of getting water out of low-lying areas, and those failed, primarily a result of storm surge. So lots of things that we need to kind of consider that. So here are some of the pictures. We saw that in the Hurricane Center, where we just are blowing the water inland. So if you're blowing, imagine that you have a bowl of water and you blow on it, you can actually push the water up on one side. Now waves will come back to fill it back, but the wind keeps pushing. So the stronger the winds, the greater the storm surge. There's also a drop in the pressure that can create a little bit of a rise in the sea level, but it's certainly most of the winds. So in this thing, they do show you what that is going to be like. You get erosion on the oceans or on the sea shore, and the water starts coming in. It's going to be very, very powerful. And once that water comes in and these continuous wave action, you're going to start to pound buildings, and that's just not going to allow anything to kind of be saved from that devastating impact of the storm surge. So what I'm going to do here is I'm going to pause for a second and Alt-P. And this is a video that I want to watch with you, just 2.5 minutes long. It is some storm chasers that stayed in Gulfport Beach, Mississippi. Now, we actually stayed in this hotel. This is the highway along the waterway, Highway 90. And you'll see the onset of water coming in, and then waves on top of that. So this is Katrina. This is one of the most destructive storm surges that had ever been recorded, about 28 feet above sea level. So now it's coming into the hotel. I don't know why people are there. The hotel's a pretty solid structure. But you'll see that vehicles are floating. That noise is from wind going through some of the destruction. Here's the lobby.
Here of our hotel. We're completely underwater. This first floor here. There's chairs close by.
Now there's nobody in that car, but the water's pushing up against the brake lights. You can see that it becomes buoyant in just a couple of feet of water. Lots of force with waves. This is all the way up to the top. I've been to this hotel afterward and watched this video.
Well, the only shot I can get is out our fourth floor. We're 4 stories up. You can see the water, the surge is dramatically risen.
You can see why it's so devastating and so many people died, because that's really terrific wave action. Just look at the debris and the garbage all over the place. Totally destroys everything. Pretty impressive stuff. So that's just an interesting video that I wanted to show with you. Okay, going back here. Let's see. So what are the influences of it? How fast it's moving, how strong the winds. The sea coastline is going to have this, and we're going to be talking about this with the tsunamis as well. So if it's shallow, the water rushes up easier if it's a gradual slope. If it's a steep slope in the water to the land, then it's a little bit less devastating. But you can see all the boats that go inland and they get out of harbors, they destroy roadways. It's just crazy amount of destruction. Now, how do we know how strong storm surges are going to be? We use this model called SLOSH, and this is something you definitely need to have. So SLOSH stands for Sea, Lake, and Overland Surges from Hurricanes. And it's a model that they use based on wind speed and the coastline and all the bathymetry and all the depth of the water along the coasts and the elevation of the topography, where they are able to calculate this. Now, Hurricane Katrina, very interesting fact, and I think you should write this down, is that the
the storm surge was actually about 8 feet greater than they expected at the time. And the reason was Hurricane Katrina, when it hit the United States, was a Category 3 on the Saffir-Simpson scale. So it was a major hurricane. But earlier in its life, it had been a Category 5. And so what happened is that wall of water sloshed up based on the stronger winds, and then it didn't take those strong winds to keep it there. It's sort of like trying to move a refrigerator. It takes a lot of force to get the refrigerator moving, but once you get it moving, the force that you have to give it is a lot less to keep it going. So that's what was happening with the storm surge. So these models keep getting updated, and that is what SLOSH does. Okay, and they use this to try to understand where, based on the tide, where the most threat's going to be. So in this example, they have the MEOW, they call it, the maximum envelope of water. And it gives you an estimate of the potential inundation from the hurricane. So they're showing you these areas just on the east side of Louisiana into Mississippi, that this is where the storm surge will be the most. Then they have these things called MOMS, lots of fun little acronyms. MEOW is kind of fun to know what that is. You don't need to know all of them, but we do give you an idea of where the storm surge probability is going to be the most. Now, why do I need to know this? Because I need to know where to evacuate people. So I was telling you that Katrina had a 28-foot storm surge. Well, in 1969, there was a hurricane that I think you should know. It's Hurricane Camille. It was one of the strongest storm surges, and it hit about the same area in the video that we just saw. And the storm surge was about 20 feet above sea level. So they said, well, that was a Category 5. This is a Category 3. We'll just evacuate people who are less than 20 feet above sea level. That's where the evacuations will be mandatory. Okay, 28-foot storm surge. A lot of people were caught in the storm surge that didn't think they needed to evacuate. So that was sort of a failure of our understanding to get people out of there. So there are some problems. So a lot of times you'll have mandatory evacuations and then voluntary evacuations. And it really is a good thing to get people to evacuate. Keep in mind, we want people to evacuate before storms, tropical storm force winds are coming into that region. So we need to get them out ahead of time. But the reality is you can't force people to evacuate. If they stay behind, they're sort of on their own. Now, we talked about the heavy winds associated with the eye wall, and sometimes the local National Weather Service issues a eye wall warning. And this is one of the scariest warnings I think ever issued, because what happens during an eye wall wind warning is that if you call 911, during that time, no one will come to protect you. It's too dangerous. So it's one of those times where you're totally on your own. It's a scary idea. So when they say you should evacuate, evacuate. That would be a good thing. They're not going to force you out of your house, but a lot of people get injured because they think they can ride it out, and that's not good. So looking at the detail of some of these maps of when we're going to, how strong is the hurricane before we evacuate. So the emergency managers use this SLOSH, and based on hurricane evacuation studies, they're actually able to determine when they're going to evacuate people and exactly where that is. So again, lots of information here. I mean, look at this if it hit New York at certain areas. And these are the kind of things you have to look out for. So we're trying to estimate the impacts, and there's a lot of detail and there's a lot of small, subtle features that make it really difficult. So when the Hurricane Center or the emergency managers say we need to evacuate, please, if you live on the shore, do that, and do that early. So we have to know about all sorts of people who are vulnerable, whether they're prisoners or they're old people or there's hospitals. That is important that we get that information out as soon as possible. So that information may come out county by county, or in Louisiana, they have parishes, which is just like counties, or cities. And that information is in the hurricane local statement. So we're going to be talking about that later. Hurricane Local Statement is a National Weather Service product. Almost everything else is coming from the National Hurricanes Forecast Center. Now, inland, we know that floods are the primary causes for tropical cyclone-related fatalities, including many who were children. And this is especially true inland at the higher elevations. So we're looking at Tropical Storm Allison in 2001. It's just a tropical storm, but there were areas of 20 to 30 inches of rain. That's going to cause amazing flooding. And then everything that we talked about with flash flooding is going to come true with the hurricanes. So speed of the storm matters, the size of the storm, what kind of rain bands, the antecedent conditions, was it wet ahead of time or has it been dry, that kind of stuff. What's the terrain? Is it interacting with other weather systems, ground saturation? All those antecedent conditions and current conditions really change the influence and the impact of these things. So rain is generally greatest with slow moving storms. You get flash flooding. If you go into the higher elevations, we've said this before, higher elevations are going to be more prone to flooding. So here in North Carolina, along the shoreline, it's not as much flooding, but you get that extra lift, creating the water to come out up in the Appalachian Mountains. And so you get a lot of problems. And that is going to be some of the biggest things that go along with hurricanes, especially inland. Now, there are web products, we've talked about this, flash flood watches, hydrologic statements, whether there's river floods, we remember this. We have this hydrograph looking at whether we're going to have flood stage events. This is a moderate flood, the action, minor, moderate, and then major flooding, and maybe record flooding. So all these things we've talked about before are ways that you can get more information. Looking at the rivers, we've talked about the river forecast centers. We talked about QPF, quantitative precipitation forecast. That's here. So they try to give you that information. Hurricane Harvey was getting 40, 50, 60 inches of QPF forecast. And we knew that was going to be a really major event. So, and then we do have local forecasts as well. So flooding, big time important. So everything we talked about with flash floods also plays a role here with hurricanes. Now, high winds, this is going to be problematic too, right? There can be a lot of destruction. Some of these winds are going to be equivalent to maybe a category 1, category 2 tornado. Sustained, they don't have the upward force, so they're not quite as devastating, but they do provide incredible amounts of force on trees. The trees form near where the water table is lower, so the roots don't have to go that deep to get water. So those trees are the ones that come down. I was in Tallahassee during a hurricane. There was live oaks down all over the place, and people's cars were crushed by these trees that were this big around. Really bad hazards with the tree downs. Power lines come down. Everybody's losing their power and due to the high winds. So lots of mess with this stuff. And then we do the storm probabilities as we start saying, this is where we think there's going to be tropical storm force winds. We'll be talking about that in the next section. Give you some idea of the wind strength. Here's a breakdown of all the categories on the Saffir-Simpson. Winds are about 111 miles an hour at a category 3, and it'll cause extensive damage. You get to category 5 and you're 157, that's catastrophic damage. It is going to be amazing amount of damage because it's just continuous wind with gusts well up in the 150. That's up there category, or EF3s type winds, maybe even EF4. Pretty amazing what can happen with that wind. So you don't want to be there. Now, when you look at a building, high-rise buildings, you got all the windows that are blown out of this building. When you go to the top of the 30-story building, it averages about 20 miles an hour faster. That's one Saffir-Simpson scale category higher than it is at the surface. So keep in mind, higher buildings are going to be worse because the winds are slowed down by friction near the ground, and they're going to be strongest at the top of these buildings. So that would be a very scary place to be. I've actually seen buildings that get moved a little bit and they become unstable. You don't want to be in a high-rise building when a hurricane's hitting, especially a major hurricane. Now, after landfall, this is important. The winds will die down really rapidly. We've talked about killing hurricanes when you have more friction Putting it over land, you also lose the water source and the latent heat. And all of those within about 12 to maybe 24 hours are going to go even from a major hurricane back below hurricane strength in terms of the wind. But look what happens even to tropical storms. They last as tropical storms for a very long time. So you inland, you'll get wind damage to trees and branches. Even though it's not a hurricane, it'll stay at tropical storm strength for quite some time. And sometimes the wind will actually expand, like the amount of area covered by tropical storm force winds will get larger. Now, another hazard, and this is handled by the Storm Prediction Center, is going to be tornadoes. And so anything that we've talked about with tornadoes are possible. We're not going to talk too much about these in this case, but notice that when you've got these spiral rain bands, which we've talked about, especially on the front right quadrant, that's where these things can become tornadic. So if you look at all those little storms, they're not really supercells, they're not long-lived rotating thunderstorms, but they have a lot of vorticity, what we call them. Shear creates this spin, and that's where we get tornadoes. Over water, there'd be waterspouts. Over land, they're spin-ups, but they're definitely damaging, and they're tornadoes. So that's kind of what we think about in terms of the right front quadrant when it comes to tornadoes. And again, every time it comes in there, it should enhance Fujita scale classification of tornadoes. You're going to get local forecasts, try to help people out. But remember, they're the ones issuing the tornado warnings. The watch is going to come from the Storm Prediction Center. Now, in the questions here, I want you to put these questions in there and be careful because there's trickiness to them. So don't worry about getting them right, but just be aware of some of the answers because they're going to be pretty important that you do that. So I'm not going to give you a lecture when you can look at this stuff for yourself. That is what we're going to be talking about in this section. The next section we'll be talking about will be forecasting, a little bit of emergency management. Now, the decision-making section, we are not going to be talking about, but if you wanted to go through there and just kind of skim it quickly, just understand how much work goes into helping people survive a hurricane. How much emergency managers, people who are working with local police and fire departments, with the electric company, with gas companies, with making sure there's clean water, with roads and streets to clear the streets to make traffic possible after the hurricane hits. There's just so many people that get involved in this weather operation. This is a huge endeavor on many different levels, federal, state, and local emergency managers that do that. So if you wanted to take a look at this, feel free to do that. That is not what we're going to be doing. And also one last thing too, is you can go to a glossary of some of the terms if you want to make sure you understand that. And then at the end, you'll be taking the quiz once you get through section 3 on this thing. So that is our hurricane preparedness, chapter 2 on the hazards. That'll be your next lecture. And then the next lecture will be the final part of this thing. 3 parts. Hope you enjoyed it. Talk to you later. Bye-bye.